stage of signal is this is 1. It is e raised to minus 80 u of t. This one is minus 1, so it becomes e raised to minus 80 u of minus t. Okay, so this is the diagram for this equation. Now we have, so what we have x of s is equal to minus infinity to infinity x of t e raised to minus st dt. This is equation number 17. Okay. And the previous equation was 16, next is 17. So we can write x of s is equal to minus infinity to infinity e raised to minus 80 u of t minus e raised to 80 u of minus t e raised to minus st dt. Therefore x of s is minus infinity to infinity e raised to minus 80 minus st u of t dt minus integration of minus infinity to infinity e raised to 80 to minus st u of minus t dt. This is equation number 18. So in the first integration we write here, in first integration we have u of t. So limits of integration will be from 0 to infinity, and for second summation because of u of minus t, the limits of integration are from minus infinity to 0. So we can write x of s is equal to 0 to infinity e raised to minus 80 e raised to minus st dt plus minus infinity to 0 e raised to 80 e raised to minus st dt. Therefore x of s is equal to 0 to infinity e raised to minus of a plus s t dt minus infinity to 0 e of a minus s to t dt. Therefore x of s is equal to e raised to minus of a plus s t divided by minus of a plus s, 0 to infinity minus e raised to so we can write here it is minus of 1 by a plus s, 0 minus 1, we replace the values of integration, minus 1 by a minus s, 1 minus 0. So we can write 1 by a plus s, 1 by a minus s. So we solve it, it is a plus s, a minus s equation number 19. So here poles are at minus a and at plus a. Now we have to draw the ROC for this. So ROC for this, so we have x of s is equal to 1 by s plus a 1 by a minus s. This is equation number 20. Now the first term is casual and it has pole at minus a. So ROC is what? Sigma greater than minus a. And the second term is anti-casual and it has pole at plus a. So ROC is sigma plus a. So combined ROC is therefore ROC. Now we have to draw the diagram for this. So here is minus a, it is plus a, so this diagram shows the ROC for our equation. Now we have to write the Laplace transform of sine wave. Laplace transform of sine wave. So consider an input signal, we write here. Consider input signal. So x of t is a sine of omega t u of t. This is equation number 21. Okay. So from definition of Laplace transform, we write here from definition of Laplace transform, we can write x of s is equal to what? Minus infinity to infinity x of t e raised minus st dt. Therefore x of s is minus infinity to infinity a sine omega t u of t e raised to minus st dt. Question number 22. Okay. Now because of the multiplication of u of t, limits of integration will be from 0 to infinity. Okay, so we write this equation as xs as 0 to infinity a sin omega t e raised to minus st dt. So equation number 23. Now we have the trigonometric identity. What we have trigonometric identity is sin theta is equal to e raised to j theta minus e raised to minus j theta divided by 2j. So we can write this equation number 23 as x of s is equal to a integration 0 to infinity e raised to j omega t minus e raised to minus j omega t divided by 2j. So it is e raised to minus st dt. Now we can write this equation as it is a by 2j constant outside the integration 0 to infinity e raised to j omega t e raised to minus st dt minus integration 0 to infinity e raised to minus j t e raised to minus st dt. So we can write x of s is equal to a by 2j Laplace transform of e raised to j omega t minus Laplace transform of e raised to minus j omega t. So this is equation number 24. So now we have standard Laplace transform pair. Standard Laplace transform pairs. So the first is e raised to a t u of t. Its Laplace transform is 1 by s minus a, and here ROC is sigma greater than a. So we can write Laplace of e raised to j omega t will be, it is 1 by s minus j omega. So ROC greater than j omega. Similarly we have e raised to minus a t u of t, and its Laplace is 1 by s plus a, ROC greater than minus a. And similarly we can write the Laplace of e raised to minus j omega t is 1 by s plus j omega, and ROC is minus j omega. Okay, now we have all these values, or we have all the Laplace transform. So we write, put these values in equation number 24. So equation 24 becomes xs is equal to a by 2j is constant. It is 1 minus s j omega minus 1 by s plus j omega. So it is a by 2j into 2j omega. We solve it cross multiplication and we solve it s square plus omega square. So we can also write this equation as x of s is equal to 2j get cancel, a omega by s square plus omega square. Okay. Now we have to draw the ROC for this. So here we write for ROC, for the first term, ROC is sigma greater than j omega, that is sigma is greater than 0 plus j omega. For ROC only real part is considered, therefore ROC of first part, here imaginary part is there, so ROC of this first part is sigma greater than 0. Now for the second term, ROC is greater than minus j omega, that is it is greater than 0 minus j omega. But here also in this case also consider only the real part, so we can write ROC sigma greater than 0. Now the combined ROC is, we write here, combined ROC of first and second term is sigma greater than 0. So the Laplace transform, this is a standard Laplace transform pair, that is A sin omega t u of t, its Laplace transform is A omega by s square plus omega square. ROC is here sigma greater than 0. Now we have to draw a diagram here. This is sigma, this is j omega, so sigma greater than 0. So we draw here, this is point of origin, so this diagram shows the ROC. In the next lecture we will see the Laplace transform of cosine wave, damped sine wave, damped cosine wave, all these.